As you can see, we have placed all the values according to the points we were given. For example, on 0, 0, we were given 0 pressure, therefore we have no temperature. When we are on 5 pressure, we have 163 of temperature, and it keeps going on according to the data given on the problem. In this case, we have temperature of pressure. We have 87.97 plus 34.96 natural logarithm of P, then plus 7.91 square root of pressure. So then the first thing that we will do is derivative. So then we will write the derivative of 87.97, that it's 0 because it doesn't have a rule. Then it's the natural logarithm, but it's multiplying, so we pass it dividing over 34. Then we have it plus 7.91 over the square root, but since it's a square root, we have to pass it to we have to put the value of the exponent, but it's negative because the x goes down and it goes up, the value. And then you have to make a chain rule, and then you have to multiply. So now you will have 34.96 over P plus the value when you multiply 7.91 times 1/2, and then you put the P goes down because it has a negative exponent, and this is your answer.
Here, in this case, when you have already the formula done, you will need to plug in the number 10 in pressure, since the question is asking you number 10. In this case, temperature derivative when it is 10 of pressure, you will have 34.96 over 10 plus 3.955 over square root of 10. The next step you'll do is again the derivation of temperature when pressure is 10 is equal to 3.496 when you have the answer of this function or equation, plus 3.955 over 3.1622. That is the answer of square root of 10. Then you will need to simplify, and you will have the derivation of temperature when you have pressure of 10, and it is 3.496 plus 1.25, and the answer will be 4.7467 when it is 10 in pressure.
In this problem, we have that pressure is 70. So we plug in 70 in pressure, and we have the temperature derivative of 70 is equal to 34.96 over 70 plus 3.955 over the square root of 70. If we derive again, temperature of 70 is equal to 0.4994 plus 3.955 over 8.3666. If we derive again temperature of 70 pressure, we add 0.4994 plus 0.4727, and we have a temperature of 0.9721 when pressure is 70.
In the next graph, we can see that the temperature and pressure are changed depending on their axis. On the y-axis, we had temperature and we changed it into pressure. And in the x-axis, we had pressure and we changed it into temperature. This is all depending on the information we gained while solving the other problems, and we can see that the values relate and are congruent with each other.